Benzopyrene. Benzopyrene BPDE or BP is a polycyclic aromatic hydrocarbon and the result of incomplete combustion of organic matter at temperatures between 300 degrees C and 600 degrees C. The ubiquitous compound can be found in coal tar, tobacco smoke, and many foods, especially grilled meats. The substance with the formula CH is one of the benzopyrenes, formed by benzene ring fused to pyrene. Its diol epoxide metabolites, more commonly known as BPDE, react with and bind to DNA, resulting in mutations and eventually cancer. It is listed as a Group 1 carcinogen by the IARC. In the 18th century, a scrotal cancer of chimney sweepers, the chimney sweep's carcinoma, was already known to be connected to soot. Description: Benzopyrene BPDE is a polycyclic aromatic hydrocarbon found in coal tar with the formula CH. The compound is one of the benzopyrenes, formed by a benzene ring fused to pyrene, and is the result of incomplete combustion at temperatures between 300 degrees C and 600 degrees C. History: In the 18th century, young British chimney sweeps who climbed into chimneys suffered from chimney sweeps carcinoma, a scrotal cancer peculiar to their profession, and this was connected to the effects of soot in 1775 in the first work of occupational cancer epidemiology and also the first connection of any chemical mixture to cancer formation. Frequent skin cancers were noted among fuel industry workers in the 19th century. In 1933, BPDE was determined to be the compound responsible for these cases, and its carcinogenicity was demonstrated when skin tumors occurred in laboratory animals repeatedly painted with coal tar. BPDE has since been identified as a prime carcinogen in cigarette smoke. Toxicity: Pyrene, showing the base pyrene ring and numbering and ring fusion locations according to EPAC nomenclature of organic chemistry. Nervous system: Prenatal exposure of BPDE in rats is known to affect learning and memory in rodent models. Pregnant rats eating BPDE was shown to negatively affect the brain function in the late life of their offspring. At a time when synapses are first formed and adjusted in strength by activity, BPDE diminished NMDA receptor-dependent nerve cell activity measured as mRNA expression of the NMDA NR-proB receptor subunit. Immune system: BPDE has an effect on the number of white blood cells, inhibiting some of them from differentiating into macrophages, the body's first line of defense to fight infections. In 2016, the molecular mechanism was uncovered as damage to the macrophage membrane's lipid raft integrity by decreasing membrane cholesterol at 25%. This means less immunoreceptor CD32, a member of the Fc family of immunoreceptors, could bind to Ig and turn the white blood cell into a macrophage. Therefore, macrophage membranes become susceptible to bacterial infections. Reproductive system: In experiments with male rats, subchronic exposure to inhaled BPDE has been shown to generally reduce the function of testicles and epididymis with lower sex steroid/testosterone production and sperm production. Carcinogenicity: BPDE's metabolites are mutagenic and highly carcinogenic, and it is listed as a Group 1 carcinogen by the IARC. Chemical Agents and Related Occupations, Volume 10, A Review of Human Carcinogens, IARC Monographs, Lyon, France, 2009. In June 2016, BPDE was added as benzcrescine to the REACH candidate list of substances of very high concern for authorization. Numerous studies since the 1970s have documented links between BPDE and cancers. It has been more difficult to link cancers to specific BPDE sources, especially in humans, and difficult to quantify risks posed by various methods of exposure, inhalation, or ingestion. A link between vitamin A deficiency and emphysema in smokers was described in 2005 to be due to BPDE, which induces vitamin A deficiency in rats. A 1996 study provided molecular evidence linking components in tobacco smoke to lung cancer. BPDE was shown to cause genetic damage in lung cells that was identical to the damage observed in the DNA of most malignant lung tumors. Regular consumption of cooked meats has been epidemiologically associated with increased levels of colon cancer, although this in itself does not prove carcinogenicity. A 2005 NCI study found an increased risk of colorectal adenomas was associated with BPDE intake, and more strongly with BPDE intake from all foods. However, the foods themselves are not necessarily carcinogenic, even if they contain trace amounts of carcinogens, because the gastrointestinal tract protects itself against carcinomas by shedding its outer layer continuously. Furthermore, detoxification enzymes such as cytochromes 450 have increased activities in the gut for protection from foodborne toxins. Thus, in most cases, small amounts of BPDE are metabolized prior to being passed into the blood. The lungs are not protected in either of these manners. The detoxification enzymes cytochrome 451A and CY.A and cytochrome 451BO and CY.BO are both protective and necessary for benzopyrene toxicity. Experiments with strains of mice engineered to remove knockout CY.A and CY Bowen revealed that CY.AN primarily acts to protect mammals from low doses of BPDE and that removing this protection accumulates large concentrations of BPDE. Unless CY.Bowen is also knocked out, toxicity results from the bioactivation of BPDE to benzopyrene -78 dihydrodeol-910 epoxide, the ultimate toxic compound. Interaction with DNA. Thumbs Center 500 vortex metabolism of benzopyrene yielding the carcinogenic benzopyrene -78 dihydrodeol-910 epoxide. Properly speaking, BPDE is a procarcinogen, meaning that its mechanism of carcinogenesis depends on its enzymatic metabolism to BPDE diol epoxide. It intercalates in DNA, and the electrophilic epoxide is attached by nucleophilic guanine bases, forming a bulky guanine adapt. X-ray crystallographic and nuclear magnetic resonance structure studies have shown how this binding distorts the DNA by confusing the double helical DNA structure. This disrupts the normal process of copying DNA and causes mutations, which explains the occurrence of cancer after exposure. This mechanism of action is similar to that of aflatoxin, which binds to the N7 position of guanine. There are indications that benzopyrene diol epoxide specifically targets the protective 53 gene. This gene is a transcription factor that regulates the cell cycle and hence functions as a tumor suppressor. By inducing G-guanine to T-thymidine transversions in transversion hotspots within 53, there is a probability that benzopyrene diol epoxide inactivates the tumor suppression ability in certain cells, leading to cancer. Pyrene -78 dihydrodeol-910 epoxide is the carcinogenic product of three enzymatic reactions. 1. Benzopyrene is first oxidized by cytochrome 451A to form a variety of products, including plus benzopyrene -78 epoxide. 2. This product is metabolized by epoxide hydrolase, opening up the epoxide ring to yield minus benzopyrene -78 dihydrodeol. 3. The ultimate carcinogen is formed after another reaction with cytochrome 451A to yield the plus benzopyrene -78 dihydrodeol-910 epoxide. It is this diol epoxide that covalently binds to DNA. BPDE induces cytochrome 451A and CY.AN by binding to the HR hydrocarbon receptor in the cytosol. Upon binding, the transformed receptor translocates to the nucleus, where it dimerizes with on hydrocarbon receptor nuclear translocator and then binds synabiotic response elements XRE and DNA located upstream of certain genes. This process increases transcription of certain genes, notably CY.AN, followed by increased CY.AN protein production. This process is similar to induction of CY.AN by certain polychlorinated biphenyls and dioxins. Seemingly, CY.AN activity in the intestinal mucosa prevents major amounts of ingested benzopyrene to enter portal blood and systemic circulation. Intestinal, but not hepatic, expression of CY.AN depends on toll-like receptor 2TL upward, which is the eukaryotic receptor for bacterial surface structures such as lipoic acid. Moreover, BPDE has been found to activate a transposon lineon in humans. Nucleotide excision repair. As illustrated above, plus benzopyrene -78 dihydrodeol-910 epoxide BPDE forms bulk equivalent DNA adducts with guanines. Most of these adducts can be efficiently eliminated from DNA by the process of nucleotide excision repair. Those adducts that are not removed can cause errors during DNA replication, leading to carcinogenic mutations.